Today we're going to look at our final review for techniques of integration, and we want to look at integration by parts. So if you remember, the integration by parts is when we want to try to find our u and our dv, and then we end up with our v and our du. We have 4 parts, and then when we do parts, our formula that we end up integrating with parts is we'll have the integral of u dv, and our formula is uv minus the integral of v du. And so the big question becomes, how do we pick the u? And when we did our u before, we had this saying that helped us pick what we wanted to use, and it was Lipit. And the first thing for picking our u, remember this is for our u, was logarithms. If we have a logarithm, that is always our u. Next is our inverse trig functions. The p was polynomials. The e was exponentials, and finally our t was our trig functions. So if we go back and look at our first problem, we have the integral of 2x natural log of x dx. So from our Lipit, our u has to be natural log, and then our dv is 2x dx. To find our du, we take the derivative of natural log, and that gives us 1 over x dx. And to find our v, we then take the antiderivative of 2x, which would give us x squared. Now, our formula here again is uv, excuse me, wrong way, is uv, which is x squared natural log of x, minus the integral of v du, which is 1 over x dx. We can simplify that integral, is natural log of x minus this cancels here, and we just get the integral of x dx. And remember, when you do parts, what you're going to end up with is a new integral that should be easier, that should be simpler if you're doing this correct. So we get x squared natural log of x minus what is our antiderivative of x. That would be 1/2 x squared plus c. And here is our antiderivative by using integration by parts. Let's do another one. Let's do 3x sine of x. And we do have the idea of our tic-tac-toe method, which I'm going to get to in a second. But let's look at this without using the tic-tac-toe method. My u is 3x. My du is 3dx, polynomial first. That means my dv is sine of x dx. And my v is negative cosine of x. So our formula is uv, which would be minus 3x cosine of x, minus the integral of v du, which would be minus 3 cosine of x dx. So let me simplify this a little bit before we take the antiderivative again. I'm going to bring out the negative 3 and make this plus 3, the integral of cosine of x dx. And then finally, we still have the negative 3x cosine in front, plus 3. And the antiderivative of cosine of x is sine of x. And then we add our plus c at the end. And there is our antiderivative by using integration by parts. Now, let's look at how we could have done this with our tic-tac-toe method. Okay, in our tic-tac-toe method, we still pick our u and our dv the same. So my u is still 3x, and my dv is the sine of x. Now, the way the tic-tac-toe method works is your u, you continually take the derivative until you get to 0. The dv, you continually take the antiderivative. So it's minus cosine of x minus sine of x, and you keep going until you get to the same with the 0. So remember, your u has to basically be a polynomial because you have to take the derivative continually to a 0. Then we go diagonal. Our first diagonal is a plus. Our second diagonal is a minus, and we just kind of continue plus and minus. And so the first one, we have a minus here. So this is minus 3x cosine. The next one, we have two minuses, two negatives, which make a plus, which is plus 3 sine of x plus c. And you can see we got the exact same answer as we did the first time. Now remember, you could not do this with natural log because your natural log is your u, and you can't take the derivative repeatedly to 0. So this really only works when you have a u that is a polynomial that you can take the derivative of continually to 0. So let's look at another one. X cubed e to the x. And this one we can do with the tic-tac-toe method. So we have x cubed, and then 3x squared, and then 6x, and then 6, and then 0. And if we take the antiderivative of e to the x, this is just e to the x, e to the x, e to the x, e to the x. So now our tic-tac-toe method, the first diagonal is a plus, the second diagonal is a minus, the third diagonal is a plus, the fourth diagonal is a minus. So by our tic-tac-toe method, we get x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 e to the x plus c. Now, just to point out, if you would have done this the original integration by parts, your u would have been x cubed. Your du would have been 3x squared. Your dv would have been e to the x. Your v would have been e to the x. And so you would have gotten uv x cubed e to the x minus the integral of u dv, which would have been the integral of 3x squared e to the x dx. And then we would have had to do integration by parts again with this spot, and we would have had to done it 3 more times to get each of these, because first time you have an x cubed, second time you have an x squared, the third time it would just be an x, the fourth time it would just be e to the x, and then you would get our full answer. So you could still do this the traditional integration by parts, but when you have something like an x cubed in front, it takes many, many times of doing integration by parts to get your answer. All right, so there is our third review of techniques of integration, and the last review is integration by parts.